Good day to all the students of Nm31. This is part 2 of the mathematics PowerPoint presentations, and we are going to do study units 3 and 4 today. My details are all on the presentation. My emails, you are welcome to ask questions and to phone me. Please just look at the hours, and please don't phone me on a Saturday and a Sunday. I also need to rest a while. We start with study unit 3, volume, surface area of cubes, cuboids and cylinders. Now, it's so wonderful that you only have these 3. So prepare them well. Learn the formulas. You need to know them really by heart, because the formulas are not given in the exam. The cube, you need to know the words also. A cube, a cuboid, and a cylinder. And the spelling is also important. I do not mark wrong spelling correct. This is 3 words. These are the 3 words that you can learn. You have to know it. So see that you can do it, and see that you know the formulas very well. A cube is so easy. It's just volume is length, breadth times height, base area times height. If you just learn one formula for all 3 of them, then you know the formula. You don't have to learn 3 different ones, because volume of any prism is just base area times height. Now it depends on the base. The first one, the cube, the base is a square. So what's the area of a square? Side times side. What's the height? So base area times height. What is the cuboid? What's the base area? The base is a rectangle most of the times. Length times breadth. So length times breadth times height. Base area times height. The volume of a cylinder, still the same. Base area times height. But what's the base area this time? The area of a circle, because a cylinder has a circular base. Pi radius square times height. Base area times height. So just be careful. If the diameter is given, you can't work with the diameter in area. You have pi radius square. And remember, we measure area in square units. Any area of a room is in square meters. So the formula has a square in it. Remember it that way. You can use for circumference, you can use the diameter. Pi times diameter for circumference, and also 2 pi radius. There you can use both. But don't confuse yourself and just learn the 2. 2 pi radius for circumference, because that's length. That's just a straight meters or centimeters. Area, the square units, the formula pi radius square. And if the volume is given, practice some examples so that you can work out the height if the volume is given, etc., so that you can play around with the formulas. The total surface area, that's usually the more difficult ones. But also there's one formula that you can learn for all of them. And that will be, if I think of a room that I want to paint, I paint 4 walls and the roof and the floor. Say, for instance, that's what you want to paint. You have always the walls, whether it's 4 walls and the roof and the floor, or whether it's a cylinder where you have the curved surface area, all the walls going all around, curved surface area, the circular walls, and again the roof and the floor. Now, in these questions, you have to read carefully if that roof is there. Sometimes we talk about an open box with no lid, or we talk about a circular reservoir that's in a cylindrical form, a big water reservoir with no cover or no lid. Then remember, there's no roof. So what are we talking about? If I say perimeter times height, imagine yourself digging a ditch around a room, 4 walls. There stand 4 walls. I go outside, I dig a ditch around it. And I throw that ditch full of paint, liters of paint. I make it full, all around. And then imagine yourself having some fancy rollers that I put into the 4 ditches. And then I press a button and all the rollers start rolling from bottom to top. Did I paint all 4 walls now? So what did I do? That ditch that I dug around the room, was it going around once? That's perimeter. Going around once, perimeter. And when the rollers went up times height, then I've covered the 4 walls. And in a circular cylinder, it's the same. I cover the whole curved surface area. So perimeter times height will give you the 4 walls or the curved surface area. And then what's left? The roof and the floor. And the floor is definitely the base area and the roof is the same. So can you see that highlighted blue formula? Perimeter times height, that covers the walls, plus 2 base area, which is the roof and the floor. And remember, when the lid is open, or it's an open box, then you don't have 2 base area, but just 1, because that's just the floor and not the roof also. So the total surface area of any cube will be perimeter going around one side plus side plus side plus side. So that gives you the 4 sides, which is the 20 times the height. There goes the rollers up times 5, and I've got 100, which is that covers the 4 walls. Now plus the 2, the roof and the floor, that is 5 times 5, side times side, again 2 of them, so that gives you the final total surface area. Again, also this next example with a cuboid. Remember the word cuboid. Perimeter. What's the perimeter of any rectangle? 2 lengths plus 2 breadths. So 2 lengths plus 2 breadths. 3.2 plus 3.2 plus 2 plus 2. All of them together. And that gives you the 10.4. That's my perimeter. Times height, there goes the rollers, 1.4 times 1.4. And then I must add to it the roof and the floor. What is the normal area for the base, area of the floor, length times breadth, and 2 of them. So you times with 2. So make sure you have this correct. This is really free marks, and they will always be asked per volume and total surface area. If we look at that previous one, perimeter times height plus 2 base area. Now when we deal with a cylinder, the perimeter is actually the same thing what we talk about circumference. We just have another word for perimeter, but it's the same thing. It's going around once. So the formula is exactly the same. Perimeter times height, or now because it's a circle, circumference times height plus 2 base area. So I go around once, and remember here, I can work with the 20, then I must use the formula pi times diameter pi d, and times the 60 is then the height. And 2 times the roof and the floor, once for the floor, 1 for the roof, and this area of a circle, of course, with a square in it, pi radius square. If it's open, it's only 1 pi radius squared and not 2. Okay, so please, if I give you also the total surface area, you have to work backwards and make sure that you can play around with the formulas. Do those examples. Work them out yourselves. Now, when we get to geometry, there's lots of previous knowledge that you have to know. You have to know it. It's not dealt with in the study unit. That's all previous knowledge. And it's all about points, straight lines, parallel lines, and all their properties of corresponding angles, alternate angles, co-interior angles, perpendicular lines, all the different angles according to sizes, according to angles. Isosceles triangle, see that you have the spelling correct. Isosceles triangle, equilateral triangle, scalene triangle, right-angled triangle, obtuse angled triangle, acute angled triangle. See that you know all these. You have to know the 3 sides of the three angles of any triangle add up to 180. You have to know that. That's all the previous knowledge you have to learn, because it's only applied here. You learn now the new theories about circles, but all those other things are applied also, so you have to know them. All the triangle theorems. The exterior angle is equal to the sum of the opposite interior angles. See that you make yourself aware of all these. Quadrilaterals, all the different kinds of quadrilaterals. Rhombus, parallelogram, trapezium, kite, square, rectangle, all the different ones. And the sum of all the angles of a quadrilateral add up to 360. We're going to do the polygons, that's the new work, as well as all the circle theorems. And all these are going to be applied also and thrown into the questions. You can't go without it. See that you go through all these topics and know the theorems, know the properties, and know all the different names also. So let's first do similar figures. The angles of similar figures are equal, but the sides are not equal, but they're in the same ratio. You can see this as an enlargement. Sorry. In enlargement, the angles are the same, but the sides are in a different ratio. If I make an enlargement of a photo, I'm not getting taller or shorter or fatter or leaner. My dimensions stay the same, all the angles stay the same, but the sides becomes double or triple or half or quarter, etc. And how do I find that scale factor? 2 times bigger, 3 times bigger. That's what we call the scale factor. And you have to know the word and write scale factor of 2, of 5. If I ask you, describe the transformation, describe the enlargement, you have to say it's an enlargement with scale factor 2 or 3 or a third. And you have to give the center of enlargement. But now let's just look at this, similar figures. Find the scale factor. You have the 70 and the 14 that you can work with. The 25 and the question mark, you can't work with that. So you have to say the biggest, the bigger one divide by the smaller one. The 70 divided by the 14. What happened? The answer is 5. It became 5 times bigger. So that scale factor is 5. So I know the small one times 5 gives the big one, and the big one divided by 5 gives the small one. So how will I find the side that's asked? 25 divided by the 5 gives you then the 5. So similar figures, see that you know them. See that you can write them and work out different sides, or work out the scale factor, or work out the ratio of the sides. Here we actually talk about the ratio of the sides more, and not only scale factor. We talk about ratio of sides. When we get to bearings, 3-figure bearings, the word tells you how the answer should be. If your answer is 40 degrees, it will be marked wrong if you don't write the 0 in front. 040 is a 3-figure bearing. The word tells you. If it's 99 degrees, you must write 099 degrees. If it's 9 degrees, you must put 2 zeros, 009 degrees. But from 100 onwards, there's no difference. It's already in 3 figures, but everything less than 100, all answers less than 100, must be given 3 figures, so you put zeros in front to fill up those spaces. Now, when I ask you the bearing from A of B, or the bearing of B from A, your indication is the from. Where am I standing? You put yourself, go imagine yourself standing at that place. From A, go and stand at A. You face north and you start turning to the right. Stand at A, the from A, face north and turn until you see B. So the bearing of B from A will be 110 degrees. Sorry. So the next one, find the bearing of A from B. What's my key? From B. Go and stand at B. So then you face north. And how do I turn? I turn all the way to the right. I turn right. Here I'm standing at B, facing north, and I turn and turn and turn and turn. Oh, sorry. I turn here, I turn and turn and turn until I see A, only there. So there I turn all the way. And now you see, if I reach 180 here, I've turned 180, I must turn another lot. And this is where your previous knowledge come into. You have to know alternate angles. So you have to know that is alternate angles, so you can say 180 plus the 110, or you can work with co-interior angles. So if you work with co-interior angles, here this angle, one that I'm showing there, that angle is 70 degrees, 180 minus 110. So I can say the whole 360 minus the 70 will also give you the same answer. So can you see? We have to know alternate angles. We have to know co-interior angles. Bearings, always face north, turn to the right until you see. And you go and stand where? At the from. Okay, I hope this will help. And you turn always clockwise, always, never otherwise. Okay, now here we get to enlargements, which actually connects to similarity. Figures that are enlarged are always similar because they are on the same ratio. They have the scale factor, and that's really much a lot of similarities. How do I work out the scale factor? If I get the original and the image, the object, in the textbooks they most of the times talk about the object and the image. You divide any length of the image, divide by object. That's giving you the scale factor. Image divide by object. In this case, what is my object? The blue one. If you see in color, if not, this is the small one. That's the object. The image is the bigger one after I've enlarged it. My center of enlargement is a point, and a point on the Cartesian coordinate grid, the xy axis, you indicate with a bracket, the x value, a comma or a semicolon, and the y value, and then another bracket. When coordinates are asked in the exam or in the assignment, you cannot give it just 0, -1, or just 2, 3 without the brackets. If the big brackets is not around them, that's not a coordinate. So please get your writing and the way you give your answers correct. A coordinate must have brackets in front and at the end, separated with a semicolon. So make sure of that you don't lose those marks. Many students in the past exam gave me coordinates without brackets. Then it's not a coordinate. So there we have the center of enlargement. If you get the object and you have to draw the image, you start at the center, take your ruler, and you draw a line and twice the length as from the center to the object, twice the distance, and you get your new points, join them, and there's your image. So if I say, describe this enlargement, say for instance, I give you exactly as it is, the picture you see in front of you, you must say, what is it? Is it a rotation or a reflection? No, it's enlargement. You must say the scale factor. How did you get that? Image divided by object. The big one divided by the small one if it became bigger. And the center, you give the coordinates in brackets 0, -1. So make sure that you can do an enlargement or that you can describe it when it's already given to you. Then we get to polygons. Now polygons are shapes. Your first polygon will be a triangle. A triangle is the first polygon that has an included area. If I have one line, it's just a line. There's no included shape. There's no enclosed, it's not an enclosed shape. If I have 2 lines, I can only have an angle. I don't have an enclosed shape. But when I have 3 lines that intersect, I have an enclosed area. So from 3 lines, that's the triangle. 4 lines, that's all your different kinds of quadrilaterals. And then from 5, 6, 7, 8, then I can have many types of polygons. Poly just means many. Just like triangle, tri means 3. Mono, bi, is 2, tri, quadru, that's 4. Now we get to the others. Penta, pentagon, hexagon, heptagon, octagon, nonagon, decagon, decade is 10 years, decagon, 10 sides. You have to know these words. So go and learn them, write them down, learn them, and have the correct spelling for all of them. Now, a few things that you have to know. The sum of the exterior angles and 1 exterior angle. The sum of the interior angles and 1 interior angle. So that you can work out unknown angles in any type of question. So let's start with sum of exterior angles, because that's the easiest, because all of them are equal. The sum of exterior angles of a pentagon or a hexagon or a heptagon or an octagon is the same. You calculate it the same way. 360 degrees divided by the number of sides. So when it's a pentagon with 5 sides, 360 divided by 5 will give you 1 exterior angle. When it is an octagon, 360 divided by 8 gives you 45. That's one exterior angle. So the exterior angle of a triangle is 360 divided by 3, which is 120. And you see the little sketch there, it indicates you those are the exterior angles. Exterior angle of a hexagon, 360 divided by 6. The hexagon has 6 sides. That's the easiest one. And it's always, if you start with the easy one, and then you can work out all the others. So you have to remember one thing. You have to remember one exterior angle is 360 divided by the number of sides. All the exterior angles of any polygon add up to 360. Now, 360 divided by the number of sides give you one angle. Now, if I give you one angle, you say 360 divided by the angle gives you the number of sides. So the question can be both ways. 360 divided by the angle gives you the number. 360 divided by the number gives you the angle. It's like 12 divided by 3 is 4, or 12 divided by 4 is 3. So let's see the sum of the interior angles of any regular polygon. The interior angles, we have the formula 180 times n minus 2 divided by n. What is n? The number of sides. For a pentagon, it's 5. For a heptagon, it's 7. For a octagon, it's 8. You just substitute that n with the number of sides, the 6 or the 7 or the 8 or the 10. And you get the sum of all of them. So for 1, you get divide by the number, divide by the n. So you can learn this, but as I said, you can always work backwards from the exterior angle. Because if I want an interior angle, can I just subtract the exterior angle? Because they're all always in a straight line. This exterior and interior angle are in a straight line. If you look at the sketch there, the exterior angle is shown there, plus the one interior angle is on a straight line there. So it's 180. So I can just say 180 minus the exterior angle gives you the interior angle. And you can always work from that. Go and do some exercises. Find worksheets on exercises. You can't just read through it and think you know it. Even if you understand it, you have to practice, and you have to practice them and see how to work out all the different ways of asking also. So now we get to the circles. Circles, there's a few things in circles that you have to know. First of all the terminology. Radius, tangent. Radius and the tangent are perpendicular. You have to know that. The radius always perpendicular to the tangent. So if I apply it here, on this question, OD is a radius. I mean, OB is also a radius. But OD is a radius, and I've got a tangent there. So there's my tangent, the line that touches only the circle in one point. That's a tangent. So I can say ODB, the whole angle is 90. Radius tangent is 90, so ODB will be 90 minus x. Now the other one will also be 90 minus x because we have an isosceles triangle. The radius OB is a radius. OD also a radius. So they're equal. So we have an isosceles triangle. So angle DOB will be 2x. 180 minus the other two will give you angle DOB. This is the type of questions that you can expect in the exam. You have to figure it out step by step from your one theorem to the next. A theorem that you need to know, and that's most of the times asked. Angle at the center, there we have it, the 2a, angle at the center. Angle at the circumference, that point goes to the circumference, but it's on the same base. The same 2 points on the circle circumference. That's the angle at the center, angle at the circumference. And the one at the circumference is twice the one at the center. So therefore, if I ask you a question like this, 40 degrees is given. So that's the angle at the circumference. So I have to times it with 2 to get the angle at the center, which is then the value of y. In the next one, I give you the 50 there. And you have to multiply the 50 by 2 to get the 100 angle at the center. If I give you the angle at the center, you have to divide by 2 to get the angle at the circumference. You have to always work your theorem both sides. From the one to the other and from the other to the one back to the one. The angle in a semicircle is 90 degrees. What is a semicircle? Half a circle. Meaning the base will always be the diameter. So any sketch where you have a diameter, you will know that that is 90 degrees. There we have the 90 degrees. And the other one, there we have 90. Angle C will be 90 degrees. Angle T will be 90 degrees. We have to find Z in that first question. I have the 31 degrees. Now, please remember, the sum of angles of a triangle is 180. If the one is already 90, what's left? Just 90. 90, 180 minus 90 is 90. So, what do? I just subtract the 1 from 90. I've got the 31. So 90 minus 31 gives me the other one. 90 minus 1 gives you the other one, because I already have 190. I don't have to say 180 minus 90 minus 31. I can just say 90 minus 31. The other one also, find B. I've got C is 90 degrees. I have to see it because it's on diameter AB. 90 minus 26, and that gives you your angle asked. The next one is that angles in the same circle segment are equal. Like, they're on the same base. Here's the same base. There we have angle A at the circumference. They are equal. So if I look in my first question, this one is 38. YXV. So V is also 38. VWY is also 38. And also WYX will be the same as the 72. WYX will be the same as WVX. You have to identify them, subtract the one from the other one, etc. Now they ask, find angle VZW. VZW. So you can say 38. You can say here you have the 38, and that one, the W is also 38 because of this theorem. Now you have two angles of a triangle, and you have to apply your knowledge. 180 minus the sum of those two gives you the other one, the angle asked. The next question, find angle DAB. So it's that top one there, DAB, that top angle. I've got the 92. And now from B, angle ABC, the 57, I can say ADC is also 57. Then I have 2, and I can subtract the 2 from 180 to get your final answer. Carefully look, write on your sketch, see which is equal to which, what angle is equal. Apply your theorems, but you have to know them, work through them, and apply them. The other one, your next theorem, will be in a cyclic quadrilateral. Please learn that word, cyclic quadrilateral. They are supplementary, meaning the opposite angles of any cyclic quadrilateral are supplementary. They add up to 180. What is a cyclic quadrilateral? It's any quadrilateral. Quadrilateral has got 4 sides. Any quadrilateral that where the 4 sides, the 4 angles lie on the circumference of the circle. That cyclic come from circle, né? Cyclic quadrilateral. And please learn the words that you know. It is always asked. There's always a few words asked. Name, what do we call a triangle with 2 sides equal? What do we call a triangle with 3 sides equal? What do I call the cyclic quadrilateral? What do I call a quadrilateral with 4 angles on the circumference of the circle, etc. Opposite angles are equal, are supplementary. They add up to 180. If you get one, the other one will be 180 minus that one. So D, in our first example, D will be 180 minus 108. In the next example, ZWX, that inside triangle there, that will be 180 minus the 83. And the VWZ will be 180 minus this one. So in the end, I can say the exterior angle of any cyclic quadrilateral is the same as the opposite interior. So that 83, can you see? That outside angle, the exterior angle, is the same as the opposite inside. So you have to learn these and know them, please. Go through the examples, get some more. There's lots of worksheets on the internet. Go there and find worksheets on circles and practice them. You will get a combined question where you have to apply different theorems in one question. And it's very important that you practice it. Okay, angle properties of circles. There we have some, can you see? A lot of things are here applied into one question. Find the size of angle CAD. Now here we have a diameter. Look at AC. You have a diameter. You have a 90 degrees at B. You have a 90 degrees at D. And you have, what do you have? You have a cyclic quadrilateral. And you find them step by step, one by one, with the different theorems. So work through it and remember a radius. You have, in this sketch, OA is a radius, but OD is a radius. They are the same. So you've got an isosceles triangle there. And what then? The 42 degrees will also be the angle OAD. Angle OAD here, this angle. OAD. That's also 42. So I can easily work out this one. That's the angle at the center. Another theorem. Angle at the center is double the angle at the circumference. So this OCD or ACD is half AOD. So first you have to see 42, isosceles triangle, 42. 180 minus 2 times 42 gives you this angle at the center. Divide that by 2 gives you ACD. Can you see? You need all your knowledge and you need to be able to apply them. And you have to know them. Please go and do a lot of practice. This is then the end of this presentation of Chapter 3, Study Unit 3 and 4. The next presentation, Part 3, will cover Study Unit 5 and 6. Thank you.